Hello and welcome to my channel. In this video, we will learn pattern matching. Pattern matching is a relatively new feature in C Sharp. It was first introduced to the C Sharp language in version 7.0. In this video, we will explore the various use cases of pattern matching as well as we will see how pattern matching has evolved over the last few years. So first of all, let's understand what is pattern matching. Pattern matching is a process of taking an expression and testing whether it matches certain criteria or not, such as we can check if the expression is of specified type or it is matching a specified constant. C Sharp supports various different patterns which we will be exploring in this video. Pattern matching provides a more concise way of testing expressions. The different operations of pattern matching can be done using traditional if-else blocks, but pattern matching can simplify these operations from lengthy if-else statements into a more compact and readable block of code. Now let's see what are the different patterns that are available in C Sharp related to pattern matching. So pattern matching was introduced in version 7.0. In this version, we got constant pattern and declaration pattern. So let's open up the Visual Studio and understand these two first. I have opened up my Visual Studio and I have created a class pattern matching. And to understand different patterns, I have created different classes for this demo. So I have a rectangle class that has two properties, length and height, and both are of double type. Then I have triangle which has base and height. Then I have a circle class that only has a radius property. And at the end, I have a square class that has a property length. Okay, so now let's first try to understand constant pattern. The constant pattern can be used to test whether an expression is equal to a specified constant. The most common use case of constant pattern is to check whether a specified object is null or not. So let's create an object of rectangle class. I have created an object and I have specified height as 7 and length equal to 3. And now what I can do, I can create a method within my pattern matching class. So I have this method now is shape null and it is taking a rectangle type object, and within it what we are doing, we are checking rectangle is null. So guys, because of pattern matching, we can use this is keyword and check the type of an object. We can use is null and we can also check else if rectangle is not null. So we can use either is null or is not null depending on the functionality that we are building. Okay, for now let's keep it as rectangle is null. So what we can do, we can invoke our method is shape null. Let's create this method as static so that we can invoke it without creating an object. Okay. And now let's call is shape null and pass the rectangle object to it and run the program. Okay, if you notice here, we are not getting any message, means the rectangle was not null. That's why we did not throw this argument null exception. But suppose if I pass null value to it, what will happen in this case? We will get the exception value cannot be null. So guys, this is our constant pattern. Now let's understand the declaration pattern. The declaration pattern can be used to determine at runtime whether an expression is of a certain type. So what we can do with declaration pattern, we can check the types. If any object is of rectangle type, or maybe we can check if it is of triangle type. That kind of validations are possible using declaration pattern. So let's understand this with the demo. So I have created an object of square class. Now let's create a method in which we will use the declaration pattern. So I have created this method edge shape square. It is taking a parameter of object type, and within this method I am checking if shape is square, then print shape is a square with the length of square dot length, else we are printing shape is not a square. And if you notice here, we have used this syntax. What is happening here? We will check if shape is of type square, and if it is of type of square, then we will typecast that object to a square type and store that object within the square variable. Once we have that value in square variable, then we can easily invoke the dot length property on that, because length property is available in square class. If you remember, in square class we have the property length that is of double type. So let's try to invoke this method. I will pass this shape that I have created here, and let's run the program. You will notice we are getting the message shape is a square with side of length 5, because we have created the object with length 5. And let's suppose I create an object. Okay, I have created an object of triangle type, and let's try to pass this one to our edge shape square method. This time, of course, this check will fail and we will come to the else block. You can see the output. We are getting the message triangle is not a square. So we are going to the else block and printing the message which is available in that particular block. So this is declaration pattern. Using this pattern, we can check if an object is of some specified type or not. Let's go back to slides. After C# 7.0, we got C# version 8.0. In that version, three new patterns were introduced by Microsoft. First one is where pattern, second one is positional, and the last one is tuple pattern. Let's go back to Visual Studio and understand these also with help of a demo. Let's remove this code. Let's first understand the where pattern. The where pattern can be used to match any expression and then assign it to newly declared variable. So the purpose of a where pattern is to assign an expression to a variable rather than testing an expression. So let's create an object of rectangle class. Now let's create a method that will check if length is divisible by 3 or not. So I have created this method. Let's understand what is happening here. So it is expecting a parameter of object type, and within it we have a if block. In this if block, first we are checking if shape is rectangle. If the shape is rectangle, we are storing that shape object in rect variable, and after doing it we are checking the length property, and we are storing that length property in the length variable. If you notice here, we have this var space length. So basically we are declaring a variable and storing whatever value is there in the length property. And in the second part of the if block, we are checking if length is divisible by 3. Basically, we are checking if the length can be divided by 3. If yes, then we are going ahead and printing this shape is a rectangle with the length which is multiple of 3. So let's try to invoke this method. I will pass my shape object. Okay, so currently the length is 9, and we know length 9 will be divisible by 3, and this test should validate to true, and we will print this line of code. So let's run the program and see if it is happening. So as expected, we are printing the shape is a rectangle with the length which is multiple of 3. But let's say if I change it to 19, this time shape is a rectangle, but the length of this shape or the rectangle is not divisible by 3. This time this will not print this line of block. To prove that, let's add a else block also. This shape is a rectangle. However, length is not a multiple of 3. Let's run the program. You will notice we are getting the message as expected. This shape is a rectangle. However, length is not a multiple of 3 because this time length was 19. So this was where pattern. Next pattern is property pattern. The property pattern can be used for checking and comparing values of properties. The property pattern will check the property of a object and try to match it with some constant values. Let's understand with help of a demo. This time let's create an object of triangle class. So I have a object of triangle class where I have the base as 4 and height I have used as 6. Now let's create a method in that we will implement the property pattern. So I have created a method is specific triangle which is expecting a triangle parameter, and within this method we are checking if the object that is coming is of triangle type, and if it is of triangle type then we are storing that object in specified triangle variable, and along with that we are also checking the properties of the triangle. Okay, we are checking if the base is equal to 4 and height is equal to 6. So if you are getting an object that is of triangle type and that triangle has base as 4 and height as 6, then this expression will evaluates to true and we will print this line on console. Okay, so currently I have base as 4 and height as 6, so this should run and print this line. If I run the program, sorry, we have to invoke the method also. So let's invoke this method is specific triangle and pass the triangle object to it. You will notice we are getting the message shape is a triangle with a base of 4 and height of 6. Whereas let's create a different object of triangle class. Let's call it triangle 2, and this time I will change the base to 10 and height to, okay, and let's pass the triangle 2 object this time. This condition will evaluate to false and we will not print this line. Let's run the program. You will notice there is no message because this time the properties base and height are not matching what we have provided in our triangle object. So guys, this is how you can use the property pattern. Next type of pattern is positional pattern. The positional pattern is useful when testing a type that can be deconstructed. Deconstruction is a process of unpacking types into parts and storing them into new variables. Let's understand this with help of an example. So within our rectangle class, let's add a method. I have to call it deconstruct. And guys, you have to use this particular name for this method, and we cannot change the name of this method because C# compiler will look for this method, and based on this method only, it will deconstruct the properties that are available in the object. Once we have added the deconstruct method in our class, we can start doing the deconstruction of object using it. So let's create an object of rectangle class. I have created this rectangle object, and in this I have length as 20 and height as 4. So let's say I have to store these values within some variables. For that, traditionally what I have to do, I have to create some variables for length and height, and then I have to set these variables like that: rectangle dot length and height equal to rectangle dot height. And guys, because the length and height is of double type, then let's change the variable type here also. double, and double. These many line of code we have to write to get the properties if we don't use the positional pattern. But with help of positional pattern, we can concise this line of code like that. Let me show you how. Let's first test this line of code and see if it is working. So I have added a console.write line here. Let's run the program. We are getting length is 20 and height is 40. Okay, now let's try to replace this with the positional pattern. I will say where, then I will use my brackets, and within this I can say L and H like that, and I can say this is our object. So what will happen here? It will say we are using the rectangle object. Okay, so it will go to the rectangle class and it will find the deconstruct method here. And what it will do, first it will create two variables L and H, and it will invoke the deconstruct method, and whatever the parameters or the variables passed there, that will be coming here as L and H, and those L and H variables will be assigned to property length and height. So this is how the positional pattern will work, or the deconstruction of object will work in C#. If I run the program, I will get the same output. Length is 20 and height is 40. But now we have deconstructed the object using just one line of code. Along with positional pattern, we have received a new pattern in C# that was discard pattern. Let's try to understand this also with help of our rectangle class. Let me create a method. So I have created this method with name is length 20, and that is expecting a parameter of rectangle type. And within this method, I am checking if rectangle is 20, comma discard. So what is happening in this method? We are deconstructing the object that we have received here, and then we are comparing the properties. So we are checking if length is equal to 20, then we are printing rectangle has a length of 20, and we are using a underscore here because we don't want to compare the height of the rectangle. We just want to check if the length is 20, then it's good enough to print this line of code. So let's run this program. You can see we are getting the message the rectangle has a length of 20. Let's try to pass one more rectangle that does not have length of 20. Let's change it to 10. I will rename it to rectangle 2, and again I will invoke isLength20 method. Okay, now if we run the program, you will notice for first object where we have the length 20, we are getting the message the rectangle has a length of 20, and for the next one we are getting the rectangle does not have the length of 20. So guys, this is how you can use the discard pattern. Next pattern that we have in the list is the tuple pattern. Let's remove this line of code. The tuple pattern can be used to pattern match multiple input values. The tuple pattern is a particular way of using the positional pattern, but the object we match on it is not deconstructed as it is already a tuple. So we will not deconstruct the object like we did here. We will directly use the values because it is a tuple, so values are already deconstructed. So let's understand this with help of an example. So I have added a method with name return description of shape. The return type of this method is string, and I am taking three input parameters. First one is shape, second one is length, and last one is height. So based on the shape and length and height values, it will decide whether the input is for a small rectangle, is for a medium rectangle, or it is a large square. If none of these conditions are matching, we will send an output as this is not a valid input. Okay, let's see how we can use this method. So I will invoke this method return. So I have invoked my method with multiple set of inputs. In the first one, I am passing rectangle with length and height as 2 and 1. So it will match with the first condition. Second one will match with the second condition. Third one, we are passing shape as rectangle, but we are passing length and height as 200. So it will not match with any of the inputs which are available here, and it will print this is not a valid input. For the fourth one, I am passing square as the shape type, and I am passing 1 as the length and 1 as the height also. But the condition that we have specified in our method, that is square of length and height 8. So it will not match any of the condition in this case, and it will also print this is not a valid input. In the next one, I have passed length and height as 8. So it will match with the square condition, and it should print this is a large square. In the last one, I have passed the length and height as 8, but the shape string I have passed as new shape. So this will also not match with any of the condition, and we will get this is not a valid input. Before running this program, let's put console.writeLine so that we can see the output which we are getting here. Okay, if we run the program now, we will get this is a small rectangle for the first input. We will get this is medium rectangle for the second set of inputs. Then similarly, we will get this is not valid input, not valid input for the next two, and then we'll receive the this is a large square for this in particular input, and at the end we will receive this is not a valid input as expected because we have passed it as new shape. So guys, this is how you can use the tuple pattern. Let's now understand the patterns that were introduced as part of C# version 9. The first one is relational pattern. The relational pattern can be used for comparisons by testing how a value compares to a constant using comparison operator. Let's understand this with help of an example. I have created an object of circle class and I have provided radius as 110. I have added a method with name isBigCircle that is expecting a object, and if that object is of circle, then it will validate if the radius of the circle is greater than or equal to 100. If it is true, then we will print this is a big circle. Let's create some more objects of circle class and invoke this method. I have created three objects and I have passed radius as 110, 80 and 100, and I have invoked isBigCircle method three times using all three objects. Let's see what we will get as output. Okay, so we are getting the message this is a big circle two times because for second object we have the radius as 80. So in that case, this particular expression will evaluates to false because we have the condition radius greater than or equal to 100, but it will receive radius as 80. So guys, this is how you can use the relation pattern. In relation pattern, you can use the operators greater than equal to, less than equal to, greater than, less than, or equal to operator. Next pattern is type pattern. Like the declaration pattern, you can use a type pattern to determine at runtime whether an expression is of a certain type. So with this pattern, we can check if the object that we're getting is of maybe of a rectangle, of circle, or a triangle. Let's understand this with an example. So I have added this method type pattern matching demo. This is expecting an object, and once object is received, it will check if object is integer type. If not, then it will check if it is of string type. Else it will check if it is of a list of integer, and we can also check if it is a decimal or float. So this is the example of type pattern. Here we can check the type and we can use the operators that are available in C sharp. So we can use or, and these kind of operators are also available for us. So let's invoke this method. Okay, so I am calling the type pattern matching method with these kind of inputs. First time I am passing an integer, then string, then a list of integers, then a decimal value, and after that a float value. So let's see what we will get when we run the program. You can notice we are getting the output as expected. For the first one, we are getting number is 5 because this is of integer type. For second one, we are getting the string in uppercase is hello world because we are getting the string, and after that we are changing it to uppercase. Okay. For the next input, we are receiving the list of integers. So that's why it will get that list of integer, and we are accessing the count property of that list, and we are printing it on the console. So that's why we are getting number of elements in list is equal to 4. If you check the input, we have passed 4 integers to this list. For the next one, we are getting this is a decimal type, and again we are getting for the last one this is a decimal type because we have passed decimal and float values. That's why for both these conditions it will match with this particular case and it will print this particular line. So guys, this is how we can use the type pattern. And guys, all these patterns can be used with switch statement. Let's understand this with an example. Let's first see how we can use the pattern matching concept in switch statement. Let's create a method that will calculate the area based on this shape that it is receiving. Okay, so I have added this method that is expecting an object, and it will calculate the area based on the shape it is receiving, and it will return that in a double format. Because the return type of this method is double, let's see what it is doing. So it is using a switch statement, and based on the shape it is checking the case. If the case is null, then we are not doing anything and we are throwing the argument null exception. If the shape is square, that time we are checking the length of that square, and based on that we are calculating the area and returning that. If the shape is rectangle, that time we are using length and height property, and we are returning the area as the product of length and height. And if it is a triangle, then we are accessing base and height properties. Based on that, we are calculating the area of the triangle and returning that. And if none of the case is satisfied, that time we are throwing a new exception of type not supported exception. Let's try to invoke this method. Okay, so I have created a circle object. Let's invoke calculate area method. Let's create a variable where area equal to calculate area and pass down the circle to it. And once we have received the area, let's print the area using the console.writeLine. We can see we are getting the result 314.159 because the area is calculated based on this particular formula. Let's try to check it for a rectangle also. So I have created a rectangle object with length equal to 10 and height equal to 5, and I am passing down that rectangle object to my calculate area method, and I am printing that again with the console.writeLine. If you notice, we are getting the area as expected. Area is 50. So guys, basically based on the shape that we are receiving, we are using the switch case statement based on that condition, and we are calculating the area of that respective shape. So guys, this is how you can utilize switch statement with pattern matching. Now let's understand the switch expression. In C# version 8.0, switch expressions were introduced. Let's understand this with help of an example. So I have created a method calculate area switch expression, and this is also expecting an object shape. But if you notice the syntax here, we are using the switch expression statement here. Let's understand what is happening here. So it is using this switch statement, and again it is checking the shape object that we are receiving, and if the shape is null, then it is using this lambda syntax. And guys, we will understand the lambda syntax in our future videos, but the lambda syntax is nothing but a method declaration. So this is a method call, so whatever we have written here, that will be returned. So if the shape is null, that time we are returning this particular exception, argument null exception. But if the shape is circle, that time we are getting the length property using the var pattern and calculating the area and returning that, because again we are using the lambda expression. So whatever is after the lambda expression, that will be returned from here. Similarly, we have circle, rectangle and triangle classes here. If none of the cases are matching here, for that we are using this discard operator, that is underscore, and we are throwing not supported exception. So guys, let's try to invoke this particular method and see if it is also giving us the right output. Let's first create a circle object. Okay, let's run this program. We can see we are getting the area as expected, 706.85. Let's try to test it for a square also. So I have created a square object with length of 12, and I am passing down this square object now, and let's call it area 2 and print it on the screen. If I run the program, I will get the area of circle as 706 and area of the square is 144. So the code is working as expected, but this time we are using a switch expression to calculate the area based on the shape that it is receiving. That's it for this video guys. In this video we have understood all the type of pattern matchings that are available in C#. In conclusion, we can say pattern matching has evolved over each version of C# language, and we have explored the various different patterns that C# supports. Overall, pattern matching is a very powerful new feature in C# which can be utilized to make your code more concise and more readable. Thank you for listening, and I will catch you in the next video.